Hi friends, welcome back. If you are a 12th class student, this is the most promising video for you. If you are an 11th class student, you might skip this video as well. It's not a very important for you as this is going to be there in the 12th class. So basically we're going to start with types of relations. We have studied that what the relations are. Now when we are classifying, we are observing whether a particular relation follows a given property or not. So based on some properties that we will learn that while classifying, that on what basis a particular relation is categorized as one relation. So that we are going to study, and this is a short question in the CBSE board. If you are a CBSE board student, a short question of 4 marks from this particular domain. Okay, now this is a domain for your board. I hope you must be getting clear with the domain right now. Let's begin with the part. Let's start with type of relations. So till now we are quite familiar with Cartesian product, then we have done domain, codomain. Now we will be studying, okay, now if we get a particular relation after applying a rule, then what kind of relation is that? Is there any, are there any symmetric relations which we can classify? Okay, these are the same kind of relation, or they are following a pattern. Okay, so broadly there are 3 categories in types of relation. We're going to study one by one, and the relation which follows all the 3 categories. Okay, now you can say that somebody is a good football player, somebody is a good cricket player. That's how you're classifying. Okay, there can be a person who can be good in all sports, so that person we call all-rounder. So here we call that relation as equivalence relation. Let's start with the first of its kind, that is called symmetric relation. Okay, now let me change the color of pen so that it becomes visible. Now this is visible. So first kind of relation is called as basically symmetric relation. Okay, now what does the symmetry mean? Okay, when we call something is symmetric, it means there is some mirror in between that, and here if we talk about the relation, so what does that actually mean? That if you are having x comma y in a relation, symmetry means if there is another pair which is of the form y comma x, means if I write x comma y where x is belonging to A and y is belonging to B, in the given relation there should be element y comma x present, then we can say the relation is symmetric. Symmetric means when you in one pair you have A comma B, so for every A comma B you are having a B comma A. That's how we call the relation as symmetric. So if I say that in this case 1, 2, 3, so now again don't compare it with the original set. You don't need to see that if 1 is related to 2 or what. Whatever is given in the relation, here it is given as 1, 1. You just have to see that whether it is following that property or not. Now this is A comma A itself, means of course we cannot write the set twice. So 1 is related to 3 means 3 should also be related to 1. If that is the case, it's a symmetric. But suppose there would have been one element more, 1 comma 2, then this would not have been a symmetric relation. Why? Because for this element 2 comma 1 is not present. So even if for the one of the element the symmetric pair is not present, then the overall set cannot be, overall relation cannot be termed as the symmetric relation. Okay. Next of its kind is reflexive. Most easiest to understand. Every element is associated, like whenever you are seeing your reflection, what you are seeing? Yourself, right? So if I am saying they are ordered paired of this kind, it means y is nothing but the x itself. Like for every element, like as now let us read what is written here, that R is a reflexive relation if this belongs to R for every A belongs to A. Now in this case there is a condition that A for all, like this symbol stands for all. So the condition here is that if 1, 2, 3 is there in the set A, okay. So in relation you should have 1 comma 1, 2 comma 2 and 3 comma 3. So if you find an element for which you don't satisfy this condition from A, now again if 1 comma 2 is there, it does not have any effect on the reflexive nature. Why? Because for every element of A, that is the first set, you have its reflection in set B. So that is basically reflexive. When every element is at least associated to itself, then we call the relation as reflexive relation. Again, note the condition here that if suppose A is 1, 2, 3, 4. Now in the relation you are having 1, 2, 1, 1, 2, 1, 2, 2, 3, 3. Now if this relation is symmetric, why? 1 is related to 2 means 2 is related to 1, that is present. 1, 1, 2, 2, 3, 3 satisfies the condition that whenever there is y comma x is there, x comma y, there is also the y comma x. Now if I want to term it as reflexive, it is not a reflexive, although it has reflections for 1, 2 and 3, but this is not present. So if I make it 4 comma 4, now this relation is possessing both the qualities of symmetric relation and the reflexive relation. Okay, now I hope this is clear. Let's look onto the third relation, which is nothing but transitive relation. Now this is a bit tricky to understand, and the questions related to this will be they might be bit complicated in the boards as well. But for JEE, most of the times you will be given a set, two sets. There will be a relation defined, and it will be asked that whether it is reflexive or it's an equivalence. Equivalence will be going to just study after this, or it's symmetric, or it's reflexive. So transitive is the most complicated one to understand, because reflexive was the most easiest one. It's reflexive means the reflection should be present. Symmetric means there should be symmetry, like if this is this, then this should also be related to this. That's how the symmetry goes. Okay. Now transitive means that if there are two elements present like this, okay, these both belongs to R, then for a relation to be transitive, A should be related to C. So it's as if your family is a perfect example. Like if you are having a brother, okay, and your brother is also having a cousin brother, or so automatically you will be related to that person as a brother. Okay, if you are a male, I am considering right now. So that is basically called transitive. But suppose if the first would have been if I would have started with sister, so if I would have said that B is your sister, okay, B is your brother and C is B's brother, okay, so now you won't have been classified as the brother of C. Now let us look that if I am writing the relation as depends like on the definition. I was just trying to give maybe once we figure out. Now if I am saying that you are this is so I am saying B is brother of A. Now if I am saying B comma C, then I am saying C is brother of A. Now if I write A is comma C, this should be present. Now if this is true, this will be a transitive, which means C is brother of, which in this case would have been transitive. Like I mentioned it, but it's not true, right? Now you can go brother, you can say brother goes for transitive. Now instead of brother, if I take father, okay, now let us see if B is the father of A, okay, then C becomes the father of B. Now can I say that C is also the father of A? No, obviously not. That C will be the grandfather. So the relation father is not transitive. Like you can understand, like if one is a brother of second, second is a brother of the third is a brother of second, so I can say third is a brother of first, right? But you cannot go the same for the father, okay? Now again, you have to be careful that for all the three relations, if we are proving that the relation is true, that if we are saying it is transitive, it should be for all values present in a given relation. I'll tell you the example once we do equivalence also. Now here I am saying R is transitive if A comma belongs to R, B comma belongs to R, then this should imply, now this word is very important, if this is present, then it will be transitive. Now it fails only when there exists ABC such that, again, it has nothing to do with the elements of A. The only relation which has to do with the elements of A is reflexive. Apart from that, it only depends on what elements are present in relation. Now suppose 1 comma 2 is there, 2 comma 3 is there. Now this becomes only transitive. B is related to A, C is related to B. So C should be related to A. That's how it goes. So this should be now clear. Now again, you don't need to worry that whether 1, 2, 3. Now even if there would have been 4, something like that. So although in your domain of this thing, only 1 comma 2 is there. So that is enough. Like if whatever is given in the relation is following this condition, it's true. The most refined relation is the equivalence. Like you can say that in case of triangles, if we go from symmetry, isosceles, which becomes two sides equal, then right angle, then equilateral. Okay, so equilateral, we say that it's had the properties of scaling, it has got the properties of like that. Equivalence means it has all the properties, although the corollary which I have drawn is not correctly because each of them are different, but as we are moving towards the symmetry in case of triangle, we can try to think of that. Okay, so equivalence means if the relation is all three. Now suppose if I am writing 1 1 1 2 1 3, then 2 3, then 2 2 3 3, and now if this relation I want to categorize, if I want to say whether it's equivalence or not, so I have to check it needs to be symmetric, it needs to be reflexive, it needs to be transitive. Okay, now again, what does it, if you are checking this relation? Okay, now first of all we should know that what is the set A from which this relation has come, because for reflexive we need to do that. Now if my A is, if I say 1 2 comma 3, so this becomes reflexive relation. Why? Because 1 is related to 1, 2 is related to 2, 3 is related to 3. No problem with that. For symmetric, if I check, now 1 is related to 2, 2 is not related to 1. So even if one of the element is not present, it's sufficient to say that the relation is not symmetric. For transitive, I see that 1 is related to 2, 2 is related to 3, and 1 is related to 3. Or you can see 1 is related to 2, 1 is related to 3, 2 is related to 3. Like this you can see the transitive check it goes, because it's not violating. Again, it does not matter that for all it follows or not, it's not violating. But this relation is not an equivalence. Why? Because it's not symmetric. Now if I add few elements here, 2 comma 1 and 3 comma 1 and 3 comma 2, now this relation becomes symmetric as well. But let us see that whether it is still transitive or not, because now these elements need to follow the property also. So 2 is related to 1, okay, 1 is related to 1. So this is again understood, like 2 will again come related to 1, so we don't need to check for that. 2 is related to 1, 1 is related to 2, 2 is related to 2. So that's how you are going to check, like for each element you are going to make the pairs and see whether the third pair is existing or not. So 1 comma 1, 2 comma 2 you can keep up right symmetrically so that it becomes very easy to understand. Then it's 1 comma 2, 2 comma 1, 3 comma 1, 1 comma 3, and then you have that's it, 2 comma 3 and 3 comma 2. Now writing by this makes it very easy to understand. Now 1 is related to 2, 2 is related to 1, so 1 is related to 1, that is present. Then 2 is, now let's first complete for the 1. 1 is over, 1 is related to 3. Now 3 is related to how many elements? We have to again, and this was also the pair, 1 is related to 2, 2 is related to 3, so 1 should be related to 3, which is there in there. So that's how you're going to check. While saying an equivalence, it should be true for all the pair. Even if one of them is missing, it's not equivalence, okay? So you have to be very careful about this one. Now here we are considering about the numbers. In JEE Mains, most of the times, the questions will be coming like, you will be given infinite set, okay? For example, you might be given a set of maybe parallelograms or set of lines, okay? Some parallel lines, and set B might be some other set given. So the relation will be drawn and it will be basically an infinite set which you have to look and see whether it will be transitive, whether it will be equivalence, symmetric, that you have to answer. Something like that questions, we're just gonna start after this one. So If you are clear with all the relations, pause here and wait, read all that stuff again and get clarity in your mind that okay, symmetry and transitive, they are independent of the set A, whereas reflexive depends on the set A. Equivalence is combining all three together. Let's see some questions now. Let P be the relation on the set R of all real numbers defined by setting A. Okay, now this is A related to B. This should be A or B. If A minus B, something similar like question we have already done, right? So A minus B mod, basically A minus B should lie between minus 12 to 12, right? Now this is a perfect example how the questions they are coming in. Now here you are getting, okay, here it's P written, so it will P only. You can denote relation by any letter, right? On set R, okay, real numbers. Okay, now this is the most common question which might, you might see in the JEE. Something of this kind. Set R, and again I would repeat, not for JEE Advanced, only for JEE Mains. Set R of all real numbers. So A and B are all real numbers. Now you have to decide whether it will be true always or not. So if I am saying A comma B is belonging to R, what does it mean? Or P in this case? It means A minus B is less than. So for symmetric, what is the case? B minus A should be. Now when we are dealing with the mod, doesn't matter that whether we are subtracting this or this, because mod will make it positive. So if this is true for this one, then this will always be true. It means the relation will be symmetric, right? You can just check it from one example maybe, but one example is not enough to say. You have to write properly in the boards that how it is going to be reflexive. You have to show that okay, this is lying between 12, so you will write that since we are taking mod, A minus B mod is same as B minus A mod. Why? Because this is just a distance, right? So you can say that if this is less than this, this will also be less than equal to this one. Okay. So obviously for reflexive, it will be A comma A should belong to B. Now A comma A belong to P means that this element should satisfy the given relation. Okay. This means that it should satisfy the given condition. So A minus A will be equal to 0, which is less than 12. So this is reflexive as well. Okay. Now if we go for transitive, what you need to do? You need to say that A minus B less than 12, which means A comma B belongs to R, or P, sorry, B minus C mod less than 12. Again, B comma C belongs to. Now you have to show that for each of them, A comma C should belong to P for the relation to be reflexive. Okay, transitive. Now here, given a close observation, you will see that if suppose this is 1 and this is 12, this will follow this rule. Now this is 12 and this is 23, will again follow this rule. But if you relate 1 and 23, so for proving that it is not transitive or any relation, you just have to pick one example and say for this values this is not true. So you can say that for these it won't be transitive. And again, if you see that A minus B less than 12, if it would have been B minus C less than 12, and then you would have added the same case, you would have got A minus C less than 24. So it means this is the possibility for one case, like when everything is positive. Okay, so for this case itself, it's not following the rule of 12. So you can say that it's reflexive, symmetric, but not transitive. So A is the correct choice. Moving on to the next question. Now this is a good question. If R and R dash are symmetric relations, not disjoint. Now this word is very, very important. We have done disjoint means they are having totally different elements, but which is not the case in this one. On set A, then the relation, okay, this is cool. So again, it's very easy. One can easily just have a guess that it's symmetric. The most probable answer will be this. Although the answer is this, but we need to understand why answer will be this, because this might come for transitive or maybe reflexive also. Now these are not disjoint. So basically it means that there is one element which is common to both R and R dash. Basically R and intersection R dash is not equal to 5. That's what it means, not disjoint, okay. So you have to be careful about that. Now here, if this is there, now it is given that both of them are symmetric. Means if AB is present in R, B comma A will be present. Same with the case with this one. Now for elements which are not common, obviously there is a pair already present. So it's just saying, you know, A, B, C, then B, C, maybe B, D, E. So we know that this is common. So for this one there will be this thing present, opposite one. Although in case of symmetric relation you at least need even number. So this is again one of the important observation. If you have odd number of things, it cannot be a symmetric most cases, unless or until element is related to itself. So that can count for odd, but if element is not related to itself, then it will always be even number of elements present in the symmetric relation. Now here you can see that B is common, okay. So obviously for that there will be some, let me just increase one thing here, F here and maybe F here. So now you know that for both of them there will be corresponding symmetric pair present, okay. So if that is true there, in this also, and you are, you know, taking intersection. So intersection means taking that element which is common. Now if B is common, obviously its symmetric pair will also be common. Why? Because both of them are symmetric. So if A comma B is there in R, so B comma A will be there in R, and same goes with R dash. B comma A belong to R dash. Now intersection will also contain both. Why? Because it has to be present. So you can say it's for reflexives, transitive, you can just take the examples. The best way to solve all these questions in JEE is take the examples. You can take 1, 1, 1, 2, 2, 1. Now this is a symmetric relation R, then you can take A, A. Now these are not disjoint, so there must be one pair present. Suppose if I take 1, 1, 2, 2, or like this. So now if I take that these both are symmetric, now this is common, right? So this is common, so that will be present here, and that itself is. Now in this case it's also reflexive, so most the best possibility will be take the example in which you are having, you know, something common else, like 1, 3, 1, 3, 3, 1 here, and 3, why? Because both of them has to be symmetric. So 1, 3, 3, 1. So this you can easily see that this is following symmetric but not reflexive, okay. Reflexive is not at all necessary. Transitive again is more complex, so it won't go for that also. Coming to the last question for this lecture, assume R and S are non-empty relations, okay. Non-empty means there is no at least one element present in R and S in a set A. Which of the following relations given below is false? The word false is important, okay. The best way to take, you know, solve these questions, again take the example. If S and R are transitive, then their union will be. So obviously you can see that if all the elements of R, they are present, they are already in transitive, they are satisfying that thing, and S also, so their union should be. So this will be obviously true, there is no fault. Now if S and R are transitive, their intersection, now this may not be true. Why? Because the setting can be such that, you can take just example, now this is transitive here, right? But there you can have 1, 2, 2, 4, and maybe 4, 1, and then you can have different set of pair 2, 3, 3, 1, or 3, maybe this 3, you take it as 5, then 2, 5. Now if you take both of them are transitive, but if you solve for, you know, intersection, what are the elements common? 1, 2 and 2, 3. 1, 2, 2, 3. Although these two are transitive individually, but their intersection is not at all transitive, okay. Same goes for this. If R and S are symmetric, then their union is symmetric. Just look at this, that if this is symmetric and S is also symmetric, just take an example like 1, 2, 2, 1, 3, 2, 2, 3. Now this is symmetric obviously, and the other relation is also symmetric, maybe 2, 5, 5 comma 2, 3 comma 4, 4 comma 3. Now if you take their union, okay, if you take their union, now this set also will be symmetric. Why? Because here you need to see that that all the elements will satisfy that condition. There cannot be any exceptional case for that. So this is also true. Now same you can check for this one. This is also true. Now in the question it was asked which is the false statement. So obviously the B which we were getting, this will be false because these two were transitive but this was not. So this is it for this, and again practice some more problems based on these relations. It will be very, very helpful for your boards, as well as it might come in JEE mains also. I hope that you are clear with all the three relations and the superset of all relations, that is equivalence. If it follows all the symmetric, transitive and reflexive property, then we term it as equivalence relation. And the most, like I've mentioned in the beginning of the video itself, that you will be getting short question from this, and that will be given a relation and it will be asked that whether it will be an equivalence relation or not. So I hope that it was quite clear and crystal clear to all of you that how we classified what are the techniques, and if you need to prove a relation equivalence, it should be general, and while disproving, it should be one specific case. If you can prove, then you can prove that it is not that particular kind of relation. After this will be a concluding phase where we'll be combining all the questions and everything which appeared in past year IIT-JEE, IIT mains or before that. Although in JEE Advanced the questions are not observed till now as such directly, but in functions we will see the application of the sets and relations in functions. So indirectly we say that this is required for studying functions, but as such directly the questions won't be coming in JEE Advanced. Stay tuned for the next part.